This video is only part of the training required to become a competent person. Remember, no videotape or training session will make an employee a competent person. Proper training will give the employee the background to identify what the hazards and protective systems are in order to correct the situation. The individual identified by the employer as a competent person must have sufficient training in soil analysis, protective systems, and hazard recognition to effectively provide for a safe excavation. Only the employer has the authority to recognize an individual as a competent person. Finally, the individual identified by the employer as the competent person must be given the authority to take prompt corrective action, either by removing the employees or stopping work to make all necessary corrections to ensure for a safe work environment. This authority is granted by the employer only.
It's just a hole in the ground. It doesn't do anything. It just sits there quietly. But given the right conditions and the right opportunities, a simple hole in the ground can be a silent menace. It can asphyxiate you, smother you, crush the life out of you. An excavation is an unnatural opening in the earth's surface. The material that was in the excavation was pressed against the material that now forms the sides of the excavation. With that material gone, there is pressure now from the sides of the hole pushing in toward the part that isn't there anymore. To put it simply, an excavation wants to collapse. And as an excavation gets deeper, the air at the bottom may not be the same as the air at the top. It may no longer be suitable for breathing. It may be dangerous, even deadly. Hank Botterman, Safety Director.
Our goal in this video is to help you understand what some of the specific hazards associated with excavations are and how to recognize them. We're going to explain how to evaluate these hazards and decide which hazard control measures ought to be selected in different situations. And for those times when involvement in excavation emergencies may occur, we're going to help develop the understanding and recognition of certain limitations and considerations. To help prevent these accidents, OSHA has developed excavation standards.
In Subpart P of the standard, they lay out some specific excavation requirements and control measures that can be used for these hazards. The OSHA excavation standard applies to all open excavations made in the earth's surface, and this includes trenches. If excavations are going to be 5 feet deep or more, OSHA requires that a protective system must be in place to guard against a cave-in.
The employer is required to designate a specially trained person to protect the employees. This competent person has been specifically trained in the hazards, soil analysis, and protective systems that are associated with excavations. They also keep careful records. Everything observed or done must be documented. The protection of the workers actually begins before the excavation is completed. This pre-planning is necessary for effectively dealing with the hazards that might be associated with the excavation.
There should be a safety and health excavation plan. This is made up of 4 basic parts: an analysis of the work, site preparation, the operation, and completion of the work. Careful attention to these steps and their documentation will help guarantee excavation safety and keep you within the OSHA excavation standards.
Let's see what's involved in an analysis of the work. The location of the project is very important. Is it near other projects that may interfere with your project? Are there train tracks nearby? Passing trains can produce dangerous vibrations. Vehicular traffic can have similar effects. How close are the roads? And how heavy is the traffic?
What sort of access will your equipment need? Is that available? Or do special arrangements have to be made?
What is the soil composition? For instance, are there large boulders that will have to be removed with special equipment? Tree stumps that might have to be removed?
How is water drainage at the site? Will water be a problem? Will dikes have to be built or pumps installed? Many accidents and injuries result from contacts with underground utilities, so contractors should take special care in locating those utilities. That's the local one-call service. Contact them at least 48 hours in advance. And be aware of overhead utilities, such as power lines. Making note of them is a significant part of pre-planning. It's also important to be aware of the size of the excavation. How near will it be to other structures or old excavations? And how long is the work expected to take?
Know before work starts what materials and equipment will be needed, and what the protection and support requirements may be. Determine if any ground contamination is present, such as toxics or flammable materials, or if any confined spaces will be encountered. Such conditions will help to determine the type of protected equipment that will be required.
Once the analysis of the work has been done, site preparation can safely begin. The locations of the underground utilities have been marked with pop-up flags for greater durability. When excavation begins, care will be taken in those areas and hand digging will be done near the utilities to avoid accidental contact for any mismarked utilities.
Convenient access and egress, ways into and out of the site, have to be provided. Establish locations for vehicles, equipment, and tools so that they'll be safe from theft, vandalism, or just kids playing around. Remove or support any items in the area of the excavation that might interfere with work. That includes boulders, sidewalks, signs, and utility poles. Locate nearby stream beds and obvious runoff areas. If water is seen to be a problem in the analysis stage, then diversionary ditches or dikes to divert or hold off water should be constructed now. And water removal equipment should always be ready and in working condition.
Once traffic, whether from vehicles or equipment, is controlled or diverted, the digging can begin. This phase of the work is the operation. As the work progresses, it's important that the equipment operator keeps the spoil pile at least 2 feet away from its edge.
Early in the excavation operation, the competent person must analyze the soil. There are many different kinds of soil. Some kinds, such as solid rock or clay, tend to stick together. They're relatively stable, cohesive. Others are less stable and tend to fall apart or change shape under pressure. Knowing the characteristics of the soil being excavated is essential in order to select the proper protective system for workers inside the excavation.
Classifying and identifying the structure and composition of the soil being removed from the excavation is very important. 4 factors must be considered in classifying soils: job site conditions, environmental conditions, earth composition, and structure. Job site conditions relate to things like existing water, traffic, material loads, and vibration sources. Environmental conditions relate to rain and snow, heat and dryness, freezing and thawing, events that can change the character and structure of the soil.
What is the structure of the earth at the excavation? Are the soils layered or sloping? That can mean their characteristics will change as the excavation gets deeper. When the soil is analyzed, it's very important that OSHA Appendix A is used by the competent person. This appendix describes a method of classifying soil and rock deposits based on site and environmental conditions, and on the structure and composition of the earth deposits.
Soil analysis requires both visual and manual tests. Soil is generally divided into 3 types called A, B, and C.
Watch the soil coming out of the bucket. If the soil remains in large clumps, this usually indicates what is called cohesive material, material that holds together strongly and resists forces that tend to pull it apart. This may indicate type A soil. It may indicate a high clay content. If the soil breaks apart or spills easily out of the bucket, this may indicate a more granular material with little or no clay content. These soils are usually types B or C. Observe the sides of the opened excavation and the surface of the ground adjacent to it. Crack-like openings or chunks of soil peeling off a vertical side are evidence of moving ground and indicate potentially hazardous situations. Observe the area adjacent to the excavation and the excavation itself for evidence of existing utility and other underground structures, and to identify previously disturbed soil. Previously disturbed areas are never classified as Type A soil. And observe the areas adjacent to the excavation for sources of vibration. They may affect the stability of the excavation.
Visual tests can provide some qualitative information concerning soil types. The accurate